Hello grade 12, especially the upgraders, because you guys are already a step ahead, so we can just go into any topic for you. For the grade 12s of this year, well, perhaps this is the topic that's not necessarily coming in the term 1 exams, but there's nothing wrong in having a look and seeing what's coming, and perhaps gather some knowledge so that it becomes easier to receive the real stuff, the core materials when it comes. Anyway, without wasting time, we have done question 2, and this was the Northwest paper that we did recently. So we're just going to continue on the Euclidean geometry section. Just for my upgraders to not fall far behind. This is one of the heavy topics and very naughty topics. Anyway, let's read. DF is a tangent. Once we hear the word tangent, it means we can annotate. Now, I always try, guys, to do this so that I can differentiate. Now, once we hear the word tangent, we know there are some implications. The angle between the tangent and the chord, that's the tangent EF and the chord EK, will be equal to the angle subtended by that chord in the alternate segment. So this is what we have. This is the 10-chord theorem. Okay, great. Now, we can clearly see that this side is equal to that side. We understand this notation. This also tells us that this angle is equal to H3. These are angles opposite equal sides in a triangle. Okay, this is what we can see. I mean, we're already reading ahead, but it's okay. It's not a big deal. Fine. And what else do we know? We know that the tangent meets the radius at right angles. So we understand that this is 90 degrees. All right? So that is 90 degrees. Nice and easy. Again, E1 plus E2 should be 90 degrees. 10 perpendicular to radius. Very easy. Okay, guys, so this is it. Let's just move on and not waste too much time. What do we have? We are told that EKHG is a cyclic quad. So let's see, where is our cyclic quadrilateral? Let's find a color for it. Okay, so we can see the blue outlined quadrilateral is the cyclic quad. Why? Because all the vertices touch the circumference. Great. Okay, we are told KEF, this is this angle, is 35 degrees. It's already noted. O is the center of the circle. Very important piece to know. If O is the center of the circle, it means this side must be equal to this side, right? Those are AD and equal to this side. This one is a difficult one to show, but the entire length, because those are all ready. All right, not a problem, but is it really clear? I don't see it. It's not so clear. Let's use the black one. So this one, those are ready. Yeah? Easy to see. And then what else are we given? That OK is perpendicular to EH, so that's the story. Now we know that a line from center perpendicular to chord bisects the chord. So this is what we have. Okay, so quite a lot of information now. Now we can see we've got this pair of congruent triangles, Interesting. Okay, all right, okay. But now, what is this quadrilateral EOHK? It's a kite, isn't it? The pair of the opposite sides are equal, and the diagonals essentially meet at a right angle, such that the longer diagonal is bisected by the shorter diagonal. And we also understand that in a kite, the angles cut through by the longer diagonal, they are going to be bisected. Only those, but these other ones that are cut through by the shorter diagonal are not cut in half. Okay, so this we can already suggest that technically that angle should be equal to this angle and that angle. Nice and easy. So this makes these two triangles similar. They are not congruent, they are similar. Okay, great. Because the third pair should also be equal. Okay guys, let me attend to my pots. I'm cooking for tomorrow. Okay, so let's carry on. So guys, I'm trying to cook a bit of what I will need for tomorrow, but I'll cook the rest tomorrow. Okay, now we have what we have. Can you see? Few questions can be asked. Prove that EH bisects angle KEO or OEK. It can also be asked that prove that EK bisects essentially HEF. So there's so many questions we can create from this diagram. Does this diagram look familiar? A little bit. But let's leave that for now. What else can we say? Well, we are to determine, no, did I answer all questions? Yeah, EK is equal to KH. So this is already indicated over there, so we don't need to do it. Okay, so now the diagram looks a bit busy. It's safe to stay away from trouble. Now let's start answering. 4.1 with 4.1.1. It says we need to find the size, giving reasons, of angle E4. So this is the angle right there. We already know how to get to that. So we started by saying H3 is equal to angle, what is that angle? KEF. Right, this is going to be equal to 35 degrees. So what is this? This is the tan chord theorem. Okay, so, but what do we know? But what do we know? We know that angle E4 is essentially angle H3. What is this? These are angles opposite equal sides. In triangle, we can say EKH. Right, because we saw that triangle becomes an isosceles triangle. So we could see that this triangle is isosceles. Alright, given that EK is equal to KH. Okay, that's the essence of this. In fact, this reason is not complete until we say that essentially EK equals KH, because we must state it if we're going to use it, right? So therefore we understand that angle E4 is going to be 35 degrees. No complications. Nothing. Easy. So this statement and reason, answer. Easy, 3 marks. Okay, let's move on. 4.1.2. We need to find EKH. Okay, so again we are still in this triangle, so we can say in triangle EKH. What can we say there? We understand that this angle EKH plus angle E4 plus angle H3 should give us 180 degrees. The reason is the sum of 3 angles of a triangle, the one we are talking about. This implies EKH plus 35 degrees plus 35 degrees should be 180 degrees. Therefore, angle EKH should be, this is 180 minus 70 degrees, so this is 110 degrees. Okay, not a problem. Easy stuff. How many marks are we scoring there? 2. Usually the substitutions and the answer, because the reason is a grade 8 reason, not a very powerful one. 4.1.3. We need angle G. Okay, good. So we know essentially that angle G plus this angle we just found EKH, this sum is supplementary. These are the opposite angles of a cyclic quad. Okay. Sometimes I like to name it, but there's only one cyclic quad here, so we can leave it at that. So this implies that angle G plus 110 degrees is equal to 180 degrees. Therefore, angle G is equal to 70 degrees. Yeah, it's like this. Nice and easy. So this is a powerful statement and a powerful answer. Easy, 2 marks. Okay, can we do the last one here? 4.1.4. We want angle O1. Now angle O1 is this angle right here. This is the angle at center subtended by arc This is the angle at center subtended by arc, essentially EH, right? It's a reflex angle. This should be equal to, in fact, that angle itself, this angle itself, come on man, do it. Doesn't want, anyway, it is twice that angle, because that same arc subtends that angle at circumference. So we are good. So we can say angle O1 is equal to 2 times angle EKH. This is the angle at center is equal to 2 times the angle at circumference. Nice and easy. This implies that angle O1 is equal to 2 times 110 degrees. Therefore, angle O1 is 220 degrees. Nice and easy. So, again, a very powerful statement and an answer. Easy 2 marks. Okay, so 4.2 says, it is further given that EH is 24 units. So this means this length is 24 units. Now, if this is 24, knowing that a line from center perpendicular to chord will bisect the chord, it will divide into 12 units. Distances like that. Meaning EM is going to be 12 units, MH is going to be 12 units. And we are told that KM is 4 units. Now this one is 4 units. Now if this is 4 units, what does it mean? Remember, so this is fine. If that is 4 units, then what should be OM? It's the radius minus 4. Because that's still the radius. Okay, good. Now it says, and the radius of the circle, EKHG. So this is the cyclic chord. Its radius is x, okay? And we need to find the value of x, okay? Good. So this means this is x. That is x. And so is the entire radius OK. So if the radius is OK, it means this length here, OM, is going to be x minus 4, right? Very important. So these are things, guys, to master and to make sure you're perfect. Now, if we want to solve for x, which triangle is best to look at? So the best triangle is going to be the yellow triangle. You guessed it right. That's why we needed to work everything, because we will have all the dimensions and it's a right-angled triangle. So we can do Pythagoras. So this question was quite heavy. It was quite a heavy question. So this is 4.2. We know that we want to focus on triangle OMH. Now, what are we going to say? We will say, number 1, OM plus MK is equal to OK. That's very obvious. That's the radius. Right? Now, this implies that OM plus 4 is equal to x. Therefore, OM is x minus 4 units. Very important to show this, because You can't just show up with dimensions that we don't know where they come from. Ne? Very important. Very important. We can say also, we know without a shadow of doubt that essentially MH, we can write it this way, MH is equal to a half of EH, right? Why do we know this? We know that the line from center perpendicular to chord bisects the chord. Okay. Of course, one can just say line from center perpendicular to chord. You can cut it there, it's fine. So what does this mean? This also implies that MH is a half of 24. Therefore, MH is going to be equal to 12 units. Another intermediate answer. Can you see, guys, the method is important. The method is important. We can now answer the question. Then we understand that OH squared is equal to OM squared plus MH squared. This is Pythagoras theorem. Remember, this is a right angled triangle. We don't need to reintroduce that angle. It was given. Okay, so we continue. This implies that OH is x, so it's going to be squared. OM is x minus 4 squared plus 12 squared. Now we can see that a quadratic equation is coming for us. This is x squared. When we FOIL this out, it's going to be x squared minus 8x plus 16 plus 144. Thank God x squared is the same sign on either side of the equation, so it will disappear. So we can simply take our 8x to the left hand side, and we leave everything else. So 144 plus 16, this is going to be 150, isn't it? Did I say 150? Yeah, it should be actually 160, sorry. Ne? So we divide by 8. Okay, this one became easy on us. I was expecting some factorization, but it didn't happen. Okay, so this is 20 units. We were told the radius is x, and we're looking for the value of x, so we got it. So a very simple question, but the steps are necessary, because as we zoom into that triangle, remember we were not given the dimensions entirely. We only knew the radius, but we didn't know that side. We have to justify why we write what we write. So guys, I hope this is clear. That was a very nice question for 4 marks. Obviously, what matters is this answer. The rest of the gymnastics is arithmetic, but this statement and reason is key. Okay? Now I'm thinking this is also very important thereof. So we have 3 marks, and Everything else is seemingly your problem, student. So don't cry. I would appreciate some 5 marks though. The correct substitutions into Pythagoras, because this is yet another rule which is key. So for me, guys, this 5 marks should have been given. Asiyeke noba stingy sometimes, let's be fair. Students cannot fail because you guys are just trying to be very mean. Anyway, guys, this is it for this question. No complications whatsoever. Let's get to question 5. Now, question 5 is the proof. So we have shown how to do this, but there's no harm in doing it again for someone who missed the other videos and perhaps needs this. Now in the diagram, triangle PQR is drawn. You can see that with S and T as points on the sides of PQ and PR respectively, such that that's the case. Okay, so obviously, guys, when you do a proof, you write what is given first. 5.1, we are given triangle PQR with, you summarize, ST parallel to QR. And then we ask ourselves, what are we supposed to do about this triangle? We are required to prove that PS over SQ is equal to PT over TR. Now, we know that we can't do this without a construction. Now, a construction here is very easy. We just draw perpendicular heights. K and H, okay? The next one, what do we do again? We join SR and QT. Those are the constructions. So those are the perpendicular heights that we want to write. So we can call this one H and we can call that one K. All right, and what do we know about the point of intersection of perpendicular heights of a triangle? We call it an orthocenter. This means the other height would come through that very point to the other side, right? So again, just know the properties of triangles, okay? Don't joke around here. And then of course we join this and we join that. Now remember, these are constructions, so constructions must be shown with dotted lines. Okay, unless someone is using colored pencils, which is fine, but normally we just use the same pencil, so it's easier to show these like that. Then we go to the proof. So, what are we going to say? We're going to focus on 2 triangles. So we'll focus on those 2 triangles first. All right. Okay, we will say in triangle PST and triangle, say, QST. The naming for me doesn't really matter. What matters is the execution. What can we say about those triangles? Actually, I shouldn't even be saying this. I'm wasting time. Let's just jump in. We can say area. We're going to compare the areas of these 2 triangles. Area of triangle PST divided by area of triangle QST. This gives us this ratio is going to be half. Okay. Half the base, we can look at it as PS times height. The perpendicular height is H. This one is going to be half. The base is SQ. And the height, remember, this is a scalene triangle, so the height is outside. So it's going to be H. Alright, so that divides to 1. That divides to 1. And all we have left is PS over SQ. Okay, at least we've got something. What are we going to say? We can say here also. Sometimes when things look alike, we can say likewise. Area of triangle PST over area of triangle. Now the triangle we're going to focus on is this one. Okay, so that's the triangle we're going to compare this to. So this is RST. This is going to be equal to, so this is going to be a half. The base this time is PT. The height, I don't know why I'm squashing things. It's a half times PT times the height. This time the height is K. This is going to be a half times, the base is TR. The height, remember, it's a scalene triangle, the height is outside. So again, we will see K divides to 1, the half divides to 1, and all we have left is PT over TR. So we've got those two ratios. Now, how do we link the two? If we note, we will see this is triangle PST. This is also triangle PST. So this means the numerator is the same. Okay? The numerator is the same. Because the area of this triangle will always be the area of that triangle, however we look at it. Great stuff. So, what do we want to say? We want to say here, technically, but, right? We know that area of triangle PST is equal to area of triangle PST. That's the same triangle. And we can say also, we know that area of triangle QST should be equal to the area of triangle RST. Why? If we look at these two triangles, this purple one and the green one, we will notice that these two triangles have the same base, ST, right? So the reason is that same base. And then, what else? We know that these two lines are parallel. Even if we drew this height on the outside, it's going to be the same as the height of the other one outside. So they will have the same height between the parallel lines. So we can see that the numerator is the same, the denominator is the same, therefore those two should be equal. So we understand that area of triangle PST over area of triangle QST should be equal to area of triangle PST. There's just a lot of writing here, otherwise the thing is easy. Area of triangle RST, right? We are deducing this from knowing that the numerator is the same, denominator is the same. Therefore, this is the situation. The final conclusion is that PS over SQ is equal to RT. Is it RT or PT? PT, sorry. Over TR. So the proof is done. Spare that my proofs are just drifting a whole lot. I hate it when this happens, but it's because of the way I handle things. The way I handle things is the problem. Okay, all right, okay. Ideally, these equal signs must almost form a straight line. I don't know, guys, my throat is just always horrible when I do these videos. I don't know. Because when I'm not under pressure, I guess it's the anxiety, the fear of saying stupid things or doing something bad. It just catches up to me. Okay, guys, this proof is very important. It's examinable, so please know it and master it. This is in the exam. And again, it's just reproduction, so just master it. If not, cram it. These are free marks. All right, let's take the application. So 5.2. Now, usually this is the tough part. A lot of difficult questions can come, but usually it's one or two. It's never too many questions. There are some easy questions, but this is where the challenges come. Now, in the diagram below, AB is the diameter. So this is the diameter. If this is the diameter, it subtends a right angle. Okay, so we know that that would be the angle in the semicircle. Easy. Quickly, guys, we do that. And of course, O is the center of the circle. So these are radii, so they should be equal. We don't waste time. We rush into the business. Okay, very important. And then, what are we supposed to do? AB is produced. Now, once you see this word produced, it means we are extending that straight line. So it means this is a straight line. Okay, great. 2K, such that SK, can you see SK is a tangent to the circle. So if this is tangential, what does this mean? If you guys don't know about tangents by now, you are really not serious, eh? Because there's no question I have seen in the past 20 years that doesn't include a tangent in the exam. So please, guys, don't joke around here. So we can clearly see, guys, once we see a tangent, again, we know the tangent meets the radius at right angles. So this is yet another issue of a tan chord. So a tangent perpendicular to radius. Of course, this one can be a bit crazy because we can see that there's a crisscross of those angles, but I am showing it anyway. Okay, all right, okay. So what else can we say if this is a tangent? The tan chord theorem. This angle should be equal to that angle, because that's the angle between the tangent KC and the chord BC. And this chord subtends angle A at circumference. Okay. Great. There's more. We can say C4 is equal to B1. Again, we have that situation, but we can see that C2 is also equal to B1. Angles opposite equal sides in that triangle. So there's a whole lot of things. This angle A is also equal to this angle. Again, these are angles opposite equal sides in this triangle OAC. Seeing those already that are essentially equal. I don't know, how did this one become black? How did I mark this black? It's crazy. So this is the story. In fact, I made a mistake. This is not the radius, so this is out. Okay, marked something wrongly, and yeah, whatever. Okay guys, so mathetical ngembe ebukuhle esikolweni. All right, okay, all right. Now, what are we trying to get to? We are trying to answer some questions. At this point, we don't want to complicate our lives that much. But notice something, guys. Notice that BCTO is a cyclic quad. How do I know? Because that angle C2 and 3 are 90 degrees. But do you see this is also given as 90 degrees? That's the exterior angle. So when the exterior angle is equal to the opposite interior angle, then we talk of a cyclic quad. Very interesting stuff. Okay, we're told SO is perpendicular to AB. That's what we just used. And CA and SO intersected T. Now, once we see two lines intersect, vertically opposite angles will be equal. And maybe that is very important, but that's something to consider. We can easily say this angle right here should be equal to that angle. And since this is a cyclic quad now, that angle also is involved in the businesses, either as an exterior angle for both, or whatever we want to say, or however we want to link them. Very easy, guys. Very easy. We just need to keep moving. Maybe let's annotate those two, because I have a feeling they might just come in handy. So this angle is equal to that angle, equal to that angle. These two are both vertically opposite angles, but they link to that as an exterior angle of this cyclic quad we just noticed. Or we can say they link together in there. All right, okay, all right. At this point, the diagram looks a bit busy, so always try to keep it simple. Be able to see as many angles as you still want to, but annotate enough so that you don't struggle to make the links. All right, so we're going to go for 5.2.1. We need to prove that these two triangles are similar. Similarity. Triangle CKB. Okay, so this is this triangle over here, and triangle AKC, the big one. All right, okay, all right. So we're trying to compare this big boy right here. That big boy right there. Don't take my marks away. Some believe though you are trying to mess with my stuff here. Alright guys, so we're comparing this green, if this is green or light blue, whatever this color is, and that triangle. So we can already see guys, this angle here is common, right? And this angle is equal to that, tan chord theorem. So the remaining angles should also be equal. So it's done. So we can easily say in triangle CKB and triangle AKB, sorry, AKC, we know that angle K is common. Okay, number one. Number two, we know that angle C1 is equal to angle A. This is the tan chord. Tan chord theorem. Now guys, two sets proved equal. The third set is really a deduction. So we can easily just say the B2 should be equal to angle KCA. These are the remaining angles. I don't know if it is necessary, honestly, to write this third thing, but yeah, whatever. You can say, therefore, triangle CKB is definitely similar to triangle AKC. Most important is the reason here why these are equiangular. Okay? Angle. You can write the English word equiangular or whatever. So this last reason and the marks, very important. This is very, very, very important. You know. Perhaps, you know, whatever. So the mark could also be given there, it doesn't really matter. Or we can even give 2 marks for the statement and reason and then the answer, because those two are fairly easy to see. Anyway, that's done. So 5.2.2. We need to prove that angle KCT, here, that bad angle, is equal to angle T2. Okay, that's that one there. All right, not a problem. So how are we going to do that? This looks a bit strange-ish, but it's not too strange. Remember, we just proved this is a cyclic quad. So this has that angle as its exterior, but we just proved that angle is equal to that. So it's done. It's not too bad, but we just need to state that this is a cyclic quad. Now we need to get to this nice and smooth. So let's first say, well, we understand, guys, that basically C2 plus C3. These are angles. This should be equal to 90 degrees. This is the angle in the semicircle. Okay, easy, because we know that that was the diameter. We can say also, we know that angle O1 is 90 degrees. This was given. So we can say, therefore, C2 plus C3 is equal to angle O1. Each is 90 degrees. That's why. Even if you didn't write the reason, it's a very soft reason. So what can we conclude? We can conclude that basically BCTO is a cyclic quad. Okay, this is the converse of exterior angle of a cyclic quad. Because at this point we proved the angles to be equal, and so this is going to be just easy to go around. Now, what else can we say, guys? We will say, then we know that, by the way, angle T, okay, maybe let's say B2 is equal to angle T2. Now, this is the exterior angle of a cyclic quad. Easy, we just proved the cyclic quad, and that's the only cyclic quad we can see, so we don't really need to specify it. We can say, we can safely say, but we know that technically B2 is equal to angle KCA, or what did they say, KCT? Okay, KCA, anyway, we used A there, we proved it above. So somebody can find this, we can make a conclusion that therefore KCT, because it's just a short segment of that angle, is equal to angle T2. This is done. Each is equal to angle B2. We can even write each So there's many ways of killing a cat, guys. Kill it. Let it die, because that thing is very, very, very resilient. It may not die, so be very careful. A cat needs to be killed nicely. It needs to be killed nicely. So that's how I can see, guys, this works. Otherwise, I do not find a quicker way to get to that answer easily. So some questions can be quite heavy, and yet the marks don't represent that this is a serious challenge. This is a serious mark. What is given, we're not interested. But this statement and reason is key. This deduction here is obvious once we have done what we did. And of course, guys, this is very key. And essentially, the final link with each reason. Can you see? These 4 marks are not really crazy, because you can see which one is heavy, which one carries the marks. All right, so let's do 5.2.3. We need to prove these two triangles, COT, cot. Where is the cot now? All right, so there is the cot. We can see it's that small triangle there that we just stippled. So sometimes be very creative, guys. Be able to zoom into the right positions so that life becomes a lot sweeter, okay? Now we want to prove that this triangle is similar to triangle AKC. So again, we're still talking about the big triangle over that small triangle. Okay, let's see. What do we know? Well, we know that this angle here is equal to that angle, right? Because of those two radii. That's the first thing. Okay, so we can say in triangle COT and triangle AKC. It's all about making those links because we've already worked on these triangles. We understand that angle AC3 in the other one should be equal to angle A. These are angles opposite equal sides. Okay. A triangle COA with radii CO equal to AO. So sometimes the reason you can decide to split it, but at times when I'm using another triangle as a means to an end, remember we need to state that particular triangle because that's what makes us to say what we are saying. Okay, so the first pair is done, but guess what? This angle is already equal to that angle, T2 from above. So we are done. We know that essentially T2 is equal to KCT. But this time we may say A if we like, because the examiners are just trying to mess with our heads. Alright, so this is proved above. Although this is an A, but it's still part of the same line, so there's not so much punishment. Guys, once we prove two pairs, similarity has been proven because the third pair is going to fall into place, whether we like it or not. Okay? That's just the story. It will always fall into place. So for me, I don't have the intentions to waste my time, but why not? It's okay. We can also conclude that O2 is equal to angle K in the other one. These are the remaining angles. I don't know how strong this is, so we can then finally say therefore triangle COT is definitely similar to triangle AKC. And this is because of the triple A. They are equiangular. Alright, that's easy. Again, this was just a matter of linking two things. For me, guys, this is not necessary, honestly speaking. So you can decide to fuss on it. But again, check the memos. If these memos consistently do that, then it means it's supposed to be that way. Again, the teachers will give you the better guide because they attend district meetings. They know exactly what the province wants. They also know what national wants. So the subject advisors, so find out from those folks exactly what is acceptable. But with our curriculum, we never needed to write the third. But I seem to see it coming a lot in your memorandums and so. In any case, it's easy to handle it because we just deal with it anyway. Now let's do the last question, 5.2.4. Now you can almost tell that this is the suplex CT. This is the beast. This is Lesnar. Are you able to wrestle with the giants? Okay, all right, okay, we're going to find out. Now the best approach to this, we need to find where's BK. Do we see it? Yes, there is BK. It's that side. It's in that yellow triangle. Where is AK? AK is where? Is this whole side of this other triangle. Very important to look at those things. Okay, siyayibona nansi ya isijonge emehlweni. Masiqhubeke. And then we see that there's OT squared. OT is this side. All right? Okay. So this means it's this small triangle also that we just proved above. So it's coming in. Okay, nice. And there's more. Don't rush. Murife, don't run. Do not run, Murife. That's CA squared. Yewena tena siqhelwa kakubi ngo. Nanku CA nje nangoku sesingenaphi thina apha. Singenaphi kulo mcimbi. Singena khona apha eminyango. Simenyiwe mos. Simenyiwe siyangena. Okanye singena ngechova. Now kune CT squared here. The CT scan. Where is CT, guys? Yo. Jo. Gemol 1 twena jwalo. Wawana now. This already tells us that indeed, if we've got two sides of the small triangle, we are happy. And we've got two sides of the big triangle. It means these two are being compared. All right. Okay. And seeing BK, it means we need to drag BK from far. So this means, first of all, we're going to compare the small triangle and the big one. And then BK, we know that it will come from that yellow triangle and the big one. So knowing which triangles to use then means we're going to be doing simultaneous equations. And remember, this is exactly what happens. We always need to derive simultaneous equations. If you do not realize this, you are dead. So those superplexity questions, guys, they are not really anything big. Just knowing what to do and how to approach them and finding what is hiding. But remember, these kinds of questions, it's going to be a system of simultaneous equations. Meaning there is some concurrency. If we're to look at these as some different straight line equations, we can say those are concurrent. Because where three or more lines meet, we call that point of intersection a point of concurrency. But hey, remember these kinds of things, man. They make life so sweet when you understand them. And remember, this is always the best way to approach it. Look at the sides involved. Once you see where they are, you will already know what to do. Always remember, when there's a side that is the odd one out, sometimes remember there is some trick somewhere. There has to be a side that is equal to that side, and therefore you can just, link those two. So it's a very easy question, obviously, guys, once you know what to do. But when you don't know what to do, you are seriously dead. Now, first of all, we can start by looking at this BK. It doesn't matter which ones we start with. All I know is that BK over. Now, I don't really care how these were named. For me, it doesn't matter because I'm always afraid of being taken for a ride. Examiners can decide to list this, however, unless there's a standard way, it's clearly stipulated in the guidelines that, in fact, it should be on the rules that this is how you name and no other way, then it's fine. But for me, naming is not a big issue when I know what to do. Now, here's the thing. BK is on this triangle, and we proved that similarity over there. So BK is opposite C1. C1 is equal to A in the big one. The side opposite A is CK or KC. So let's say over KC is equal to. Now we need to find something that's going to bring up AK, because we can see here we cross multiplied. Now, which one of these? Is it CA? No. I'm trying to think now. Wait. This case is common, right? It's common. Now, yes. This KC on the other one. Because remember, we started with BK, and then this KC was on the big triangle. Now we are starting with KC on the small triangle. Over. Now this is opposite this, but that angle we proved is equal to this C1, 2, 3, and the side opposite it is AK. So you see, when you know how to do this, it's not difficult. You can say These are the prop sides of similar triangles in 5.2.1. Sometimes we just say that. See, pointing reference to that, we already understand. Okay, all right, and then we do the cross multiplication. We can see therefore that BK times AK is going to be KC squared. All right, okay, all right. You can call this equation 1 or you leave it like that. Just know that's a simultaneous equation. That's the first. So the most important is to derive the equation by yourself using principles of Euclidean geometry. Now we know that essentially we were supposed to compare, but now this is the similar comparison. We can say likewise, because gyafana, right? Now we can see, guys, that we have these sides of this situation right there, and we're still comparing with the bigger one. So this is these triangles that we're using now. So we use those triangles. We can see safely that we want OT to come out. So it doesn't matter which one we start with. We can start with the big one, we can start with the small one. It's not a big deal. But let's just start with the small one so that we have a clear guide which sides to choose on this one. But obviously we have CA here, so it probably is very useful to start with the big one, or we don't. It doesn't really matter. Okay, let's go on, guys. What do we have here? We can say CA from the big one over. Now CA in the big triangle is opposite that angle, but that angle we linked with which angle? O2 in the smaller one, and the side opposite that is CT. So this is exactly what we're going to say. Equal to, and of course we take that side OT because we see it's in the expression, over. Now OT is opposite that angle C3. That angle C3 is equal to angle A in the big one. The side opposite it is KC. Kibona biano, kibona yona can neat. All right, guys, so this is good. So we can clearly see KC is common, right? So we can make KC the subject. Can you see? You let the thing lead you. Of course, we're going to say these are the proportional sides of similar triangles in 5.2.3. We don't want to stress. So we want to isolate KC. Of course, first of all, we cross multiply. And I can do this quick, but let me be easy on you. So this is going to be KC times CA is equal to OT times CT. Right. Now, what are we going to do? We want to isolate KC. We can say therefore, Emanyan. What did we do now? What did we do? I reversed my ratios. My Lord, you see, this excitement is dangerous. Remember, CA came from the big, so we need to start from the big. The big is going to be CK. Yes. Or did we write KC? Sure. I started reversing things now. KC is opposite this angle. That angle is equal to that. Therefore, it's over OT. Okay. Again, guys, make sure you keep your eyes open because I could see that my ratio is going to be reversed because I messed up here when it comes to the ratio. Now we continue. This is going to be essentially OT times CA is equal to KC times CT. Therefore, if we want to isolate KC, we divide by CT. So this is going to be OT times CA all over CT. Now that looks better, because remember, we can take this and substitute there. We can say then we know that BK times AK is going to be, instead of KC, we write OT times CA all over CT. That is squared. We can conclude that BK times AK. Now when we square this, the square distributes to each one of those things there. So it's going to be OT squared times CA squared over CT squared. Again, understanding algebra, guys, because simplification is algebra, isn't it? Yes, 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 yes. Is important. So can you see these 4 marks are easy once you know what to do. Again, pay attention, as you could see a mistake easily can creep in. Nice and easy, guys, nice and easy. So of course this was not given and this was not given. It's a very important deduction. And the correct substitution, very important. Now this was already volunteered, we're not interested, but I think this one is key. This one is too easy to see. We wouldn't really worry, but again, I still feel this should have been a mark. This should have been a 5th mark, because that equation was important to derive. So again, the examiners decided they're not going to be very friendly, but this was a rather nice 20 marks. And I hope, guys, you enjoyed the exercise and you can understand the strategies that need to be employed in solving these problems effectively. Of course, it's not always easy, it's not always as nice, but once you have the strategy, I promise you, you will never go wrong. All right, guys, I will see you some other time. Goodbye. Just leave a like and re-practice this question paper. I will attach this question paper in the description below so that you can practice it for yourself entirely, in its entirety. You can even do the algebra part, you can do the sequences and series, you do the Euclidean geometry and the analytical. So that's the next piece I'm going to do. So obviously for each of the videos I'm going to do, I will attach this question paper there so that you can understand. And then of course, I'm working on this document in its entirety so that I can attach it as well in each, so that you can have a whole memorandum available to you. Should you miss the other videos and see the other videos, you won't miss the question paper and you won't miss the memorandums. Otherwise, guys, let me leave and love you. Until next time, goodbye. Oh, by the way, I wanted to talk about something. Maybe let's take the next 5 minutes to just highlight something. This is now not for students per se, but for teachers. This is for teachers now, not for students. Of course, I'm not a teacher, guys. I'm just suggesting. So this is a mere suggestion. Now let's use human psychology properly. Let's use the advantages of what we learn at school properly, guys. Teaching uses what we call operant condition. Operant conditioning. Now, the person who came with this is Sigmund Freud. Sigmund Freud, okay? So this is the man who came with this idea of operant conditioning. Now, this used the experiment by, is it Ivan Pavlov? I think so. Ivan Pavlov experiment. Now, this is essentially where a dog, is trained so that it realizes food is coming. So every time it's going to be given food, the experimenter sort of rang a bell. And then later on, the dog got food. So now they observed the dog. When the bell rang, the dog wetted its mouth because it was ready to chow. Because remember, when the dog is ready to chow, the mouth becomes very wet. Anyway, so this is operant conditioning, meaning whenever something is done, it means the one who's being conditioned is going to develop a particular expectation. So all I'm trying to say, guys, as teachers, we need to use this well, of course, not to indoctrinate people for doom and stupidity, but for good. Because remember, how we teach is going to determine how well they do. So this is why we need to understand conditioning. As you can see, you see what I'm doing here. Every time I do my work, I try to look at the diagram, because the first thing you want the students to know is to understand exactly the statements given. They need to read. Because once they see a diagram, they must not look at the diagram first. They must read. Read with understanding by interpreting the diagram from the reading. You see, that's operant conditioning, because every time they see a diagram, they will look for that, because they know there's a lot that they can find, and therefore they tend to do better. Operant conditioning, okay? And then, of course, we know that the students themselves learn by observation. Okay? So display what you are teaching. Don't expect them to just know. Remember, we're talking about high school kids. These are people who still need to be directed in a particular path. They are not yet independent thinkers. These are influenced thinkers. Yes, there are some who are gifted because of how they are raised and how gifted they are naturally, but not many are like that. So a multitude of students are actually people who need a bit of channeling. Hence, we need to condition them in the right path. All right. Now, guys, there are two principles, by the way, that facilitate operant conditioning. There's the principle of reinforcements. Reinforcements. Now, the reinforcements can either be negative or positive. Now, negative reinforcements, this is punishment. You need to punish kids when they're fooling around. And then when you're giving positive reinforcements, this is commendation, right? You commend them for good work. Commendation or reward. Some people call it a reward. Reward them. Sometimes, I know you're not getting paid enough by the department, but there's a 50 rands that you waste sometimes. You can just put up a nice challenging question after teaching a session before you continue to show them the tricks. You just see how well can they use what they have. Say the one who makes a better attempt or even get it right, here's the $50. The department definitely doesn't care. They pay you guys less, but you can use that to reinforce a very hungry behavior when it comes to learning. So guys, reinforcement's important. So please, let's understand that teaching is not just, just opening a book and some educational guidelines and then you just go through the motions and that's it. Yes, you've done your job, but awenzanga nto ingcono kunomuntu ovela adlulisa usana kunina. Kubani yena nakekela usana ngunina, wena ulidlulisile nje. So asiyenza lonto. Abantwana uba ngumzali kubo. Uba motswadi ho bona abana. How fit is fela leseya homme walona. Now that's the thing. Anyway, guys, I just wanted to highlight this. Observational learning works under the principle of so-called behaviorism. Behaviorism. This is by Mr. B.F. Skinner. All right. So this is the father of behaviorism. Now this is what says, if you show people something, they tend to behave in that way, right? For example, Mr. Skinner said, give me 5 children. it doesn't matter whether they are born from rich families or whatever. I can turn those kids into 5 different things. One, I can make them a criminal. The other one, I can make a priest. The other one, I can make a teacher. I can make a doctor. I can make just, those people who are just always complaining and wondering why they are suffering. So this just tells you that you can create something out of those kids. In fact, whatever they become is because someone is responsible for what they become. I know we always talk nonsense, if I can put it that way. That motivational talk, as a person, you can do your own thing. Remember, there's no such a thing. Nobody does their own thing, okay? That's just not true. Maybe to some extent, it is true. Of course, in science, guys, we never have a definite no and a definite yes. It just depends on what seems to carry the greatest percentage. Because, I'm one of those people who are very, very stubborn. And essentially, I know why, but you wouldn't know why. But I'm one of those stubborn individuals. In fact, I prefer to do things my way more than I do it the way others do. But at the same time, I'm very careful because I'm trained that I cannot be careless. Maths taught me not to be careless. Because all of these things I've just shown you now, how to go through a maths question and stuff, how to answer and how to present your answers in the best way. Those are the things that trained me now to not be careless in what I do. Just because I know what to do doesn't mean it's going to be successful. So I have to be very careful and cautious and align everything while I exercise a bit of flexibility. But where did I get this? It's a constellation of the things I've been observing around me. My kindergarten teachers, which is elementary school, high school teachers, university. Not so much so in university because those people are just lecturing, they don't teach. So there's not a lot you can gain from them, as in for personal reasons. But for educational and academic purposes, if you listen to the direction they're pointing you in, you stand a chance of succeeding. So folks, all it means is that children tend to come out from here. But can you see these 2 theories of psychology, operant conditioning and behaviorism? They are actually linked. They are linked because the teacher conditions so that kids can observe and therefore learn and reciprocate. And when they do bad things, you punish. Okay? When they do good things, you reward, right? And again, please know where things come from, right? Know these ones. Ivan Pavlov experiment was that dog wetting its mouth when the bell rings because it's been conditioned that food is coming. B.F. Skinner said, look, the experiment is give me 5 kids, I can turn them into anything to prove that kids, no matter where they come from, no matter what their genes, they will just become what the environment dictates. And it goes back to a book we read in high school by Bessie Head, Maru. It was written in Botswana about the differences in the ethnic groups, the Masarwa people who are the Bushmen, and the Botswana, how they were treated so badly. But guess what? A very Masarwa girl who was raised by a missioner, what was the name now? I forgot the name. Is it Margaret Kedmo Senior? Yes, Margaret Kedmo. So she took this girl, although she was one of the races that are sidelined in Botswana, took that girl in, taught her everything. She became an exquisite teacher. And then she proved a theory that says environment is everything. Heredity means nothing, okay? Can be born of very successful parents and you can just become injubatunj, rubbish, udot maspala. And in fact, you can be born by very useless individuals called parents, but you can become a golden boy, a golden girl, or even something bigger for the very whole world. So essentially, guys, this is just, a little bit of, because I know I touched on this topic on the previous video, but I kind of jumped ship because I realized, it's going to be inappropriately long and it won't really make sense. So guys, as teachers, remember, there are certain things we can apply, there are certain things we should not apply. But you see, human psychology is very important when it comes to kids, because if you don't understand human behavior, especially kids' behavior, then you will not be a very good teacher, even with the good skills that you possess. Because guess what? Kids are going to put you off by being disrespectful and disruptive, and perhaps not paying attention and not taking anything seriously. But it depends on you as a teacher to make them serious. Let me just make you an example. You know, when I started my medical degree at Medunsa, it was then called the Medical University of South Africa or Southern Africa. But then at the time I joined, they had changed the name to the University of Limpopo, because they merged with the University of the North, former TEFLOP. And so they decided this is the UL Medunsa campus and UL TEFLOP campus. So essentially, I'm a UL graduate. Now, what happens is, they had just started this thing called the MedLight program. The MedLight program, essentially, some guys who were senior students from second year for medicine, and in fact, all other subjects. Did I say subjects? No. All other courses that people choose there. You were only admitted to be a tutor in your second year for the matriculants, of course. Now, there they were just focusing on maths and science. Okay, that's all. So one of the guys who was a former teacher, former maths HOD, when he was a former school principal, who now decided to go into medicine. He was from PE. So he wanted to go home when the holidays approached, but he still had a lot of topics to cover. I don't know how he decided I'm going to teach his kids. For some reason, he just approached me as if he knew I could attempt to teach. I mean, I'm not a teacher, guys. By no means. I'm far off that level. You know, teachers are exquisite people. They change stones into bread. So I'm unable to do that. I can only put butter on the bread if it is dry. That's the job I can do, but I can't make bread from a stone. So unfortunately, sorry. So essentially, he asked me to, go and take his newly made bread just to butter it with my knowledge. So I did take that upon myself. So I would come from class, tired as I would be sometimes from clinicals, but go and teach those kids. You know what happened? One of the boys, in fact a few of the boys, because I was not that old from them. You could almost see that some of them were my age group. We may have done matric together in 2005, but maybe they decided to, take that chance to upgrade their marks. Now, they would like, this one is a small boy. Remember that guy was an old man. He could be my father even. So they had respect for him, but now they thought, this one, anyway, they would make a lot of noise in the class, commotion, and not pay attention. You know what I did? I didn't try to, worsen the situation by shouting at them, belittling them and telling them, look at me, I'm doing medicine, third year. And you know what, you guys are not anywhere near this and wara. No, I didn't do such things. I just did my job as I'm expected to. And guess what? I just said to those boys, look folks, if you feel like this class is boring, I don't mind you guys going out. In fact, don't even ask to go out. If you feel like you want to go out and cool off, please do so quietly. Don't disrupt the class. Even when you decide you're bored outside, you want to come back, just do so quietly. Remember, this is a free country. You are here to learn if you want to. If you feel like I'm wasting your time, you can easily go out and even never come back. It's up to you. But those who really want to learn something, they will sit back down there and listen and do their best to ask questions when given an opportunity to. And of course, we try and work this out for all of us to come out the best. Now, those boys went out a few times, and then when they came out, I never really made any noise. Came back, and then they would be making noise, and I'd be like, folks, we made a deal, right? If we feel like we are not listening to each other, somebody has to step out, and if you do so, please do so quietly. But all I can tell you guys, it only happened once or twice, and then after that my class was in order. because I have not seen classes. When I went to observe in other classes, people were very crazy there. And everyone would be talking nonsense. Even the very tutor would be, howling back at those kids. And I'm like, you don't do that, man. You just let people be free at the same time. Don't give in to their nonsense. Don't fall down to their level as well. You can only drop your level for them to understand something they're not understanding, but not at a barbaric and survival level, okay? So all I can say, guys, is I only taught those guys for maybe 2-3 weeks or so. And that's all I did. I mean, I was not really hired a tutor. I tried to apply for it, but it didn't go through. I only used, the opportunity that the guy gave me. And I can tell you guys confidently that by the time I left Medunsa, one of the guys I taught even knew where my room was. He came. I think I left him doing his BDS, as in Bachelor of Dentistry. Another one was doing his Bachelor of Science, I don't know in what. Another one was enrolled for physiotherapy. Others didn't tell me exactly what they did, but they all confirmed that, hey man, we passed well, thank you very much. Because you know what those kids did? To show that when you are a positive energy sometimes and you know how to deal with these people at a psychological level. Those kids actually begged me, because when that guy came back and now he took over, they were like, man, please take over. Why can't you tell him to let you be the one to teach us, because we understand better? I remember even linear programming was one of those subjects or topics that were a bit less understood at the time and even poorly taught. And as a result, many students in the government schools, from township schools, didn't really perform so well in that topic. It was always the last question on our paper one. I can tell you guys, I took them from the basics of inequalities of grade 9. I'm telling you, those guys nailed that thing. The test I designed for them, and I made it very hard, harder than the standard exams. Those guys aced it. But I could see some gaps on what my colleague, if I would call him, was doing. And so I then consolidated them onto those and gave them more lessons and more lectures. And those guys did well. So all I'm trying to say, guys, disruptive kids, you just need to know how to psychologically get them right. Okay, don't degenerate into the level that they want you to. Again, as much as you have qualified, stop shouting around. Look, I'm a teacher. I have made my life a success, and you are sitting there making noise. Let's see what you're going to be in the next 2 years. I mean, you don't talk to kids like that. Only kids can say that to each other, not an adult or somebody in a position of authority must talk nonsense back to kids or show a level of animosity or an uncaring behavior. Then you're in the wrong profession if you're like that. Even when it comes to healthcare, when you become a healthcare worker, some of you are going to become doctors, physiotherapists, dentists, you name them, occupational therapists, clinical psychologists, social workers, you name them. So you will be dealing with people at different stages in their lives, under different circumstances, and their behavior is going to be sometimes good, sometimes bad, sometimes appealing, sometimes not so looking good. You just have to know how to condition people to behave in a way that makes you perform at your best for them, not just because you're flashing your degree and what. We don't care about who you are per se. We care about what you do with what you have become. Because if we benefit from it, that's what we want. The rest is for your own personal nonsense. Keep it to yourself or amongst your friends. Anyway, guys, I just talked a lot, but I just wanted to highlight these 2 principles of human psychology: operant conditioning, which was a concept coined by Sigmund Freud. And of course, there's 2 principles around it, which is the principle of reinforcements. Is it negative reinforcements versus positive reinforcements, where when there's something wrong, you punish. But again, the punishment must not be, destruction. You don't destroy when you punish. You just punish. And punishment sometimes is very easy. You don't need to be aggressive. As I showed you exactly how I punished those guys. I just let them punish themselves. And then they realized this is crazy. They came back online and everything was good. And of course, when they do good, you just, give them things. So when I made them write that test, out of the little money that he cut for me, I put up some money for grabs for those who did well, And that's how you do it. And I realized that when they see you do things and you do them better, they tend to replicate you or emulate you. And as a result, they start to become themselves, because obviously they can copy you for a moment. But remember, kids are exploratory. They are innovative as well. So once you show them something that works, they test what they have in mind against what they saw in you. And then they start to see other ways of going around things and encourage innovation, flexibility. I promise you guys, we'll have bulletproof kids and this country can become better in a moment. Because teachers are the most important people in our lives. Anyway, guys, I hope I didn't rant too much. I'm not the guy who really likes to do separate videos and do the runs separately. I'd rather I talk about practical stuff whenever I find a chance to. At the same time, to show you that as a teacher, you need to be multifaceted in class. You can't just be unidirectional. So anyway, I hope this is it, guys. Please practice, folks. I will do a video on the last question. And like I said, on each video of this question paper, I will attach a clean question paper and this memo because I'm writing it in full. So I'm going to write question 1 also, perhaps push this down so that everything is following on nicely. I hope you guys have enjoyed this. Leave a thumbs up. Don't be shy. I see a whole lot of a mismatch here. You see views are not matching with the likes, but I guess it's people who are not interested in this. They just bump into it and just are looking to see, because I doubt, if at all, the people who watched the videos and watched it full wouldn't like it, right? It just shows that the majority is people who are not really benefiting from these videos, because if they did, they would not fail to leave a like. Again, guys, a like is not for me to be popular. I'm not interested in that. I'm actually a person who loves my own personal space. I'm not in the people's faces anyway. So for me, I just need those likes, guys, for these videos to reach as many students as possible, because I started this channel for the benefit of our high school kids, because I know what it felt like to look for information, to look for someone who can teach you better, and you don't find those, and your career or your very livelihood is at risk of not materializing, because you can see that what you have around is not good enough. Not to say you are belittling the people around you, but you can see though that as much as they're trying, but they're not quite what you need. Okay, so I started this channel for this reason. I would never have done this if it wasn't for you guys. At first, I had thought about how am I gonna do this for everyone. I didn't really think about this YouTube thing. Even when I started my channel back in the days, my channel was all about learning how to play the piano. In fact, I got obsessed by playing the piano and stuff. So I started showing videos on how to play piano. And I think I'm one of the first people to show how to play Dance with My Father by Luther Vandross on piano. Because I started to see another guy take over that. Of course, he had more views than I could because he was more popular than I would be. Anyway, I was still erratic myself. I was still learning the instrument, so there were a lot of issues with my videos. But yeah, I made that attempt. In fact, I don't know why I never thought of physical science and maths, because at the time, everything was still fresh, That was before 2011, my final year. Anyway, guys, I will keep on drilling whenever I can. Of course, I may not be as consistent as you wish, but you have my comment section. You have my email in the description of the channel. You've got my WhatsApp number, so hit me up whenever you need to. Yes, I may not respond always as prompt as possible, but I'll do my best to respond anyway, so that eventually you benefit. But be careful, guys. Don't just be obsessed with watching. Get your hands dirty. Believe me, it can take just 2 weeks to get to the right level. You don't need a month or a year. And after that, you become consistent in applying yourself. You will cruise, and you'll start to laugh at yourself and be like, here am I sitting? Why did I struggle with this topic? Why did I struggle with this subject anyway? Because we'll start to see that, come on, man, there's nothing here. You know? Anyway, anyhow, goodbye.